Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. First of all, in this insightful session of the 10th Asian Physics Symposium 2023, allow me to thank for opportunity that has given to us to present the article with the title Numerical Simulation of the Effect of Molten Salt Channel Number on Temperature Distribution in the Molten Salt Core Reactor. Before I begin my presentation, let me introduce myself. My name is Amelya Dwiyulianti. I am from Shah Kuala University, and this is the author's team from this research. Let's move on to the main presentation, which is the first introduction. The development of nuclear reactor has reached the Gen 4 reactor. This reactor wants to make a reactor that has safer, sustainable, economical, more proliferation resistant, and physically secure. One type of reactor developed in Gen 4 is molten salt reactor. This reactor uses fuel and coolant in the form of mixture of molten salt, which is generally made of fluoride salt. Next, still in introduction, passive nuclear safety is the design approach to safety features in nuclear reactors that doesn't require any active intervention from the operator or involvement of electricity to bring the reactor to safe shutdown state in the event of an emergency. One of them is natural convection. Natural convection will be occur if the hot fluid will rise to the top and the cold fluid will fall to the bottom, so that the circulation will be formed. And then simple reactor design with small size also become the focus of the researchers today. Name is small modular reactors, so that knowing the relationship between a reactor natural circulation system and the size of the reactor's geometry is essential because it affects the reactor safety. So MSR is designed with inherent safety advantage. Therefore, it is necessary to develop an MSR with a small size reactor design that can be used on a wide scale. One important aspect in the design of a reactor is thermal hydraulic analysis. Many studies on MSR has been carried out, such as research about neutronic analysis and the thermal hydraulic. So this study aims to know the effect of the molten salt channel number on temperature distribution in the MSR core. Next, I would like to explain the method of this research. This simulation is carried out in three dimensions, and the velocity of fuel is 1.47 with the input temperatures around 839 Kelvin, and the wall temperatures is set at 300 Kelvin, and this is the geometry size used in this research. And then the shape of the mesh used is hexahedral with element size of 0.008 meters. The meshing quality is the excellent meshing criteria as seen from the skewness and orthogonal quality values obtained in this research. This is the mesh of has been created for 1 to 4 channel. To see more clearly for the mesh, uh, we can see the figure 5. This is the mesh geometry for 1 to 4 channels. Still in the method section, after the mesh has been successfully created, so we continue with the setup section. First, the solver used in this research is pressure-based type with the assumption the fluid flow is in stable state, so that the simulation is carried out in steady condition and the absolute velocity formulation. Next, for the models, the energy equation is active because the heat transfer that occurs of the walls and the fuel salt channel. The fluid flow is the considered turbulent flow, so viscous condition was chosen with the K epsilon realizable enhanced wall treatment model because the type of flow is complex flow with heat transfer case. And then enter the property of the materials as shown in the table 1. And then in the boundary condition for the inlet, I use the velocity inlet. For the outlet, I use the pressure outlet, and the wall temperature was set to 300 Kelvin. For the solution, I use the simple method. This method is Ligas method uh, of the Ligas method in terms of computerization required when compared to the piezo and couple method. This is due to the limitation of this computer I use. Next, I'm going to explain the result. The first point in the result is effect of variation in the number of molten salt channels. The spectrum shows us the temperature in inlet, middle, and outlet. And the data is chosen at the y direction. This is for one channels, two channels, three channels, and four channels. And the data I plot in this graphic. It can be seen that in the inlet temperatures, uh, in the inlet temperatures for the channels is 839 Kelvin. This is the accordance with the input temperature set in the boundary condition section, as well as the graphic, which is set at the 300 Kelvin. And then in the middle area, the graphite has increased the temperature in step by step. This is because molten salt flowing in the channel. In the middle and outlet of the channel, the salt experience decrease in temperatures of all numbers. This is will be increased because the heat carried by the salt is transferred to the surrounding rapid, but it still closer to the input temperatures. In outlet temperatures back to 300 Kelvin for rapid because it was set in the 300 Kelvin. And then I would like to show you the temperature distribution in the Z direction. The data is taken in the middle for the channel and the middle for the graphic. And then the data is displayed on the graphic 6. From the graphic, we can see the temperature difference between the inlet and outlet for all number of channels. And then based on the figures 6, we can see that the highest temperature difference in the fuel salt channel is 2 channels, and the lowest is 4 channels. So 4 channels have outlet temperature more closer to the input temperatures. And then the variation of channel number also change the temperatures in the graphite section along the molten salt channels. More number of channels, the graphite will get more the heat contribution. So from this figure, we can see that 4 channels give contribution more heat. Um, the second point for the result is effect of input temperature variation. Figure 7 shows us the temperature distribution with inlet temperature variation for 1 to 4 channels. The spectrum shows us the difference in the temperature values, where dark blue contours indicate the lowest temperatures and the red contours indicate the highest temperature. And then by the figure 8, we can see that between the two inlets, the temperatures of 908 Kelvin produce a higher temperature difference. So that from this simulation, I found the temperature drop relatively higher in the high temperature. In this slide, I would like to show you the temperature distribution in Z direction with inlet temperature variation. The figure shows the difference in the color spectrum in the Z direction, and then the data I took from the blue line, and then I plot in this graphic. We can see by the figure by the figure 9, and then based on the figure 9, we can see the graphic temperature increase with the increases of input temperature, and we know that with the adding 69 Kelvin will increase the graphic temperature by 57 Kelvin. Okay, before I close this presentation, I would like to conclude my presentation. The first, the difference in output temperature from the inlet less than 10 Kelvin, and the second, however, the temperature drop is relatively higher for the high temperature flow. Uh, That's all my presentation, and I really hope advice from you. Thank you for your attention, and I say wassalamualaikum warahmatullahi wabarakatuh.